So this question is find the terminating equivalent circuit. Assume we have a load connected between A and B. Okay, and then so the next question is if we have 1 kilo ohm resistor connected between A and B, find the current flow through it. So for finding the terminating equivalent circuit, we can first find the RTH value, the terminating resistance. Okay. So in the terminating resistance, we can redraw this circuit. We replace the ideal voltage source with a single wire. So maybe I can just put some node here. Let's assume this is a node C. Okay. So now we redraw the circuit. Ideal voltage replaced with wires, and then we connect it to the resistor. This is our R1. And then at this junction node is C, is split into R2, and then go to this R3, and then we go to this node A. Here we have one split resistor R4, and then it's connected to the node B. Okay. So find the RTH between A and B. We can redraw the circuit here. If we draw the circuit, let's say we're going to start from the node A, this A node here. Okay, in this case, it will split into R3 and R4. So here will be R3, split into 2. This is the R4. Okay, so the N terminal of R3 is denoted as C. At this C node again is split into R2 and R1. So in this way, we have this R1. This is R2. Okay. And the R1 and R2 are connected together to the node B. So this is our node B here. And R4 also is connected to the node B. So in this case, we can find what is the RTH value. So clearly R1 and R2 are in parallel. And then it's series with R3. So here we have R3 in series with the parallel. R1 is parallel with R2. And then this here, and then will be parallel with R4. Okay. So now we're going to substitute the value for the R3. So R3 values, we have 4K. R1 is 2K. And R2 is 1K. Then it's parallel with R4 is 5K. Okay. Now we're going to calculate this. We have 4K plus, so 2K times 1K, we get 2K, and divide by 3K here. Okay. And then here we're going to have parallel with 5K. So in this case, we're going to calculate this. We have this 3K over here. We have 14K at the top, and then parallel with the 5K. Okay. So we finally calculate this. We get 2.41 kilo ohm. So this is our RTH. This is our RTH between A node and B node. So the next things we want to do is that we're going to find what is the VTH value. Okay, we want to find what is the VTH. So we can shift this out. Let me shift these things to the side over here. Okay, now we're going to find is the VTH value. So to find the VTH value, we can use the voltage divider. We find the voltage at C node, and then we use that C node voltage to find the voltage at A. So now we need to find VTH. Okay, we need to find the VTH. What is the VTH? VTH is potential difference between VA and VB. So we know that this VB is a reference ground, so it's a 0 volt. So we find VA, then we can find what is the VTH value, right? So from this, we can use a voltage divider. So first, we can use calculate what is this equivalent circuit, this RTH value, this REQ value. Okay, from this, let's rename this as this equivalence network RC. This RC, we have R3 is connected in series with R4, and then they are in parallel with R2. Okay, they give us the equivalent circuit for the C network. So R3 we have 4K, R4 is 5K. Then parallel with R2 is 1K, right? So in this case we have a 9K parallel with 1K. So in this case we have 9K. Okay. So in this case we have 9 plus 1, we get 10 here. Okay, so in that case we get 0.9K for the RC network. Okay, after you find the RC network, so we're going to repress, we redraw the circuit here. Okay, after we get the RC network, we redraw the circuit. So this is our 10 volt. Now it's connected in R1. In this case, it's 2K. So this is our C node. Now we're going to repress this with our equivalent circuit that we just calculated. This is 0.9K. Okay. Now in that case, we can find what is the VC, the voltage VC. So VC using the voltage divider formula is equal to 10 times 0.9K. Okay, divided by 2K plus 0.9, we get 2.9K. Okay, that we get the VC's value. Okay, so the VC values we get 3.103 volt. Okay, so now we know this VC value over here is 3.103 volt. Okay, so this 3.103 volt is going to supply split between the R3 and R4, right? So that means from this onward, this VC over here, it can act as a supply voltage, which is this supply voltage is 3.103 volt. Now so it's connected to this R3 and R4, R3, and then R4. So this is a series network. So R3 is 4K, and then we have this R4 is 5K. Okay, so remember this one is the A node, this one is the B node. So for this, we find what is the VA using the voltage divider formula. Okay, so here we have 3.103 volt times 5K divided the total resistance 9K. So the VA that we get is 1.724 volt. So you have the VA and the RTH values, then we draw the Thevenin circuit. Okay, so the Thevenin circuit, we have the Thevenin source. This VTH is 1.724 volt. Now it's connected in series with the RTH value is 2.41 kilo ohm that we get from here. Okay, and then we have this A node. This is B node. Okay, so this is Thevenin equivalence. Now we see the questions. Next question is find the currents if we have 1K resistor connected between A and B. So in between A and B, we have a resistor here. This is 1K. So in this 1K, we're going to connect between A and B. Then we're going to find what is the current. So they assume that the current flow in this network is in these directions, denoted as I. So this I is equal to VTH 1.724 volt divided by 2.41K plus 1K. Okay, so that means you calculate this, you get 0.506 milliampere.